So today we are going to learn about linear search and how will perform linear search. There is an animation related to that. So let's see that there are 9 elements or 10 elements index starting from 0 to 9 and the list A in which data is to be searched. So we have this list and we want to search this data. So let's see how it works, the linear search. So suppose we want to search number 57. So how this linear search will get performed? So it will have to match with each and every element one by one. So first it'll match with the first element, that is A of 0 and 11 element. So data is not found at this. So it will try to match it 11 with 57. So 11 is not equals to 57. Then it will compare it with some next element immediate after that. So that is 2. So 2 is also not 57, not equal to 57. So data is not found there as well at one position. And then it will compare it with the next element, that is A of 2, that is 9. 9 is not equals to 57. It will keep on doing the same thing until the data is found at particular position. Then that position will be returned. So it's very simple. We can see A of 3 is being compared with 57 and it is not equal because at A of 3 we have 13. 13 is not equals to 57. Okay. Now it will compare it with the next element immediately after that. So that is A of 4, 57. So we have a match there. So we can say element or data is found as A of 4 is 57 and we have found our data at position 4. So search is successful. Or else if element is not found in the list, it will have to traverse all the elements one by one. So this is called linear search. Just now before this one, we have just seen that how to search an element in a list of unsorted array. Now, I just want to tell you that if we'll perform a linear search, it will remain linear search whether we perform it on an unsorted array or a sorted array. So this one is a sorted array. We can perform a linear search, but finding the maximum and minimum out of this sorted array would be easier. Okay, but it will take more time than the previous one. If we'll sort the elements first, then obviously it will take more time, like if we use insertion sort for sorting the elements, it will take n square time, so that will be difficult. But if the elements are already sorted, that doesn't mean that we always can perform binary search only. We can also perform linear search on it. Let's see that it will be same as the previous. So it will compare the first element first with the element that we want to search, and after that it will try to compare it with the next element. And if they don't find the element there, the search will continue for the coming indexes and coming letters, coming digits, sorry. So it will compare it with the all the elements until we find our data at position 8. So this is how we do the linear search. So we have seen how the linear search works. Now we'll be seeing its program. Okay, linear search program. So let me include some header files. First we'll include iostream.h, and we'll include all the header files later if we need any. Okay, so first we'll start it from the main function, and then we'll declare an array, also initialize it using a dynamic method or dynamically. So I'll take any numbers here like 2, 3, 4, and then 10 and 40, and this is my array. Okay, now which element do I want to search in it? That is x, let's say. So if x, I can give it any number like 10 if I want to search at what position 10 is there in the array. Now I need to find out the size of array. So I can find out using, I'm taking n as an integer to find out the size. So this is a simple mathematics question. If I want to find out the size of whole array, I can see the size of this whole array if I want to find out number of elements actually. So how many number of elements are there? So size of whole array divided by size of one array. Size of is a operator that tells us the size taken by the variable in the memory. So it will be in bytes. So let's say it's taking uh, because it's integer, it's taking, let's say there are 5 elements, so 5 into 2, it's taking 10 bytes, 10 bytes in the memory, let's say. And the first element is taking only uh, 2 bytes. So how many number of elements will be there? So what I'll do, I'll use size of array divide by size of any element, any one element. So I'll take the first element only, and that will be ARR of 0. The element at first position, we need to find out its size, and using it, we'll divide the size of whole array with this one element. So we'll have the number of elements that will be 5 in this case, and will be 5 in this case. And we'll make a function call here. We'll call a function. I'll do it with the function calling because this is a procedural language, and we can create as many functions as we can. Void main itself is a function. So this is a modular approach in C++ and C. So we have to create functions so that there is a clarity in the program. So you can do otherwise as well. If you have any other way to do it, you can do that way for linear search. So we'll make a function call here, but before making a function call, we need to create a function. But I'll just write here the name of the function, that is search, and I'll pass the whole array to this function, and then the number of elements, and then the item that I want to search, that is x, and I'll call the result back into the this variable called result. So result will be stored in the result. Now let's create a function first, and then we'll see what to do ahead. So I'm creating a function here. So this, there is this function called search. I'll take its data type as integer, and I'll take a new array here so that I can receive the values from the main function of array in this ARR. I'm taking the same name. You can also take the different names here. Then we'll take x here. Okay, three arguments are there. So all three arguments I'm taking here. Then int I for running a for loop to search all the elements. So 4 will be taken like this. For I starts from 0, 0th element, and it will go to the from 0 to less than size of array that we have received from this this main function. And I'll do here I plus plus increment by 1. And after this I'll write if statement, that is a branching statement, and I'll write here ARR, that is our array of I. We need to compare the each element of array with our element that we want to search is X. So comparison operator is there, double equals to, and if the element got a match, then we need to return some value of I, that value, the position where we have found the element, the position where we have found the element, we need to return that position. And then we can close our for loop, or there is only one statement. We do not need these compound statements here for the for loop because there is only one statement in it. Okay, so let me indent it properly. Okay, that's already okay. Now, what if the element is not found? Then this loop will get executed fully from 0 to less than n, and it will not return anything. In that case, I want to return something, and that will be returned here. Of sorry, that will be returned here. I have returned -1. You can return anything here. Okay. So if we have not found the element, -1 will be returned. So -1 or I will be stored in result because we have called it here, this function search, we have called it here. So I or -1 will be returned here in the result. Now we need to apply again if result equals to -1, then element is not present in array, else element is found at result. So that's it, that is our program. We can also use a ternary operator here. If we want to use, we can also use a ternary operator here. Let me use that one. So how can we do that? I'll simply write here, after calling it, I'll simply write here result equals to -1. This is nothing but this is a if like statement. Okay, if for if we have used a question mark here, or because in C++ or Turbo you have a feature you can write in multiple lines. This is the same line, but I'm writing it in a multiple lines. So here I can print a message cout element not found. Okay, element not found or not present in the array, you can print any message here. And this is the question mark, this is the question mark, and this is the option when this is true. So again, let's see. This one is the condition, and after the condition, this will get printed if this condition is true. If result will get a value -1 from the function that we have created, then it will print element not found. Else, for else we use colon here in the ternary operator. So we'll print here uh, cout element found at what position we need to, sorry, then here we'll mention the variable name result and put a semicolon here, and that is end of our program. Okay, so let's see if it works or not. So let's see that if this works or not. So there is no error in it, and if we run it, we'll get the our element is at fourth position, element found at fourth position. So this was our linear search program, linear search program. So this is our linear search program. Thank you.